Good morning, Year 2, and welcome to your Monday morning maths. Now, what we're going to be doing today is we're going to be building on our understanding of multiplication and division, and more specifically in this lesson, we're going to be exploring those arrays. Okay, everyone, so just as usual, we're going to practice our supertising skills. Get ready to count the dots. Okay, remember we go so fast. This time you've got to count the yellow dots, eyes on the screen. Ooh, that was a quick one too. This time, look out for those blue dots. Amazing, brilliant. And next one. This time you've got to count the lines. Ooh, that was fast. Okay, so let's go through all of the answers. Here we are. The first one, there were 2, 2 and 1. And we know double 2 is 4 and add 1 more is 5. Well done if you got that one correct. Okay, the next one. Let's have a look. We were looking for our yellow dots this time. So we've got 3 there and 1, 2, 3 there. Double 3 is 6. Well done if you got that one. And here we were looking for the blue dots. 1, 2, 3, 4. Brilliant. If you said 4, you would have got that one correct. If you've seen it as 2 and 2, then you know that double 2 is 4. And finally, the house. We've got 2 to make the roof, 2 for the sides and 1 at the bottom. So 2, 2 and 4 is 2 and 2 is 4 and 1 more is 5. So well done if you got that correct as well. So let's look at our key vocabulary for today's lesson. Remember, this is to help develop your mathematical thinking and to help you with your mathematical explanations too. So whilst we're engaging throughout this lesson and when you're doing your independent work, you should be using some of this vocabulary to speak to people about your ideas. Okay, so our first piece of key vocabulary is the word row, okay? So remember, the row in array goes across, doesn't it? So let's do this sign for row, okay? Then we've got another piece of key vocabulary which is linked to our arrays. It's a column. Remember, a column goes down, so columns. Then we've got our equal groups and also the word array there as well. So just make sure that you're using these words throughout our lesson. Okay, so we're now on to your do now. So if you do have your worksheet there in front of you, then you'll be able to complete this alongside the PowerPoint with me. Or if you've got a piece of paper and a pencil, that's perfectly fine as well. We can complete this together. Okay, so here it's asking us to fill in the numbers, the missing numbers in the following number sequences. So let's have a look and see if we can spot any patterns to begin with. Okay, so right now I'm looking at it and I can see that we've got the number 24, 26, 28 and 30, and I'm trying to work out what's happening to those numbers in that number sequence. And I think I might have spotted a pattern that's happening in the ones. Okay, let's see if you can spot that pattern too. You might want to pause the video now so you can have a little chat with whoever's with you and tell them what you see. Or you could even just pause the video now and have a little think yourselves. Okay, so in our ones columns, I can see that the numbers are increasing and I can spot that they're part of the 2 times tables. Look, we've got 4, 6, 8, and then where it says 30, that would mean that we've made it into a 10, wouldn't it? Okay, so I can spot that they're all part of the 2 times table. I can also spot that they are even numbers. So if you said any of those things, that's great mathematical understanding. Well done to you, okay? Because this is going to help us to work out the next part of our problem. Now, let me just use this pen highlight the numbers I was on about. Here we've got 4, 6, 8, and then this has become a new 10. Because if we look here, the number has changed in the tens column from 20 to 30, okay? From 2 tens to 3 tens, okay? So we've crossed that boundary there. We've exchanged, haven't we? Okay, so remember what I said. We are increasing. They are all part of the 2 times table. So we know that each time the ones is increasing by 2. It's getting bigger by 2, isn't it? Because look, if we move from 4, 5, 6, we would have 2 jumps, okay? So let's continue the pattern and see where we get up to when we get to here, okay? So we've jumped 2 there to get to 26, we've jumped 2 there to get to 28, and we've jumped 2 spaces there to get to 30. So if we jumped 2 spaces here, what would the number be? 30, 31, 32. Superb. I'm going to go ahead and write that in there now. You should do the same if you've got it on your sheet, or you might want to write it on your piece of paper there. Okay, now let's look at this number because this is another one that we are missing. Okay, so let's have a think about how we're going to find this number. If the numbers are increasing, if we go this way, then if we go the other way, what are the numbers doing? Well, look, I can see that they are decreasing, they're getting smaller, okay? And they're getting smaller this time by 2. Look, if we started with 26 and we jumped 2 spaces backwards, then we would end up at 24 because it would go 26, 25, 24, okay? So if we were to jump 2 spaces backwards, what do you think that this number would be here? Okay, 24, 23, 22. Amazing. So let's go ahead and write that number in there now. Fantastic, everyone. Okay, I'm going to leave you now to find out the answer to the second part of your do now, okay? So you can be using all of that mathematical thinking that I've just been using to work out the answers to the second part of your do now, okay? Good luck, everybody. Here is our big picture. I would encourage you to pause the video and have a look at all of the maths that you can see happening in the big picture. I've spotted something. If we look at the logs, I can see there is 1, 2, 3, 4, 5 in one group, 1, 2, 3, 4, 5 in another group, and 1, 2, 3, 4, 5 in another group. So I know that there are 3 groups of 5, and 3 groups of 5 is equal to, well, let's count it. It's 5 add 5 add 5, isn't it? Because that's 3 equal groups of 5. So what is 5 add 5 add 5? Well, it's 15, isn't it? Because I know that 3 groups of 5 is equal to 15, okay? Let's see if you can pause the video and think of any maths that is happening in our big picture today. So here is the apple cart in the market stall. And what we need to do is we're working at the market stall today and we need to arrange the apples that we've got here on the screen. Now, the first job is to count how many apples there are altogether. So go ahead and count those apples now. If you said that there are 10 apples, you would be correct. Now the next job is to arrange the apples into rows that have 5 apples on each. Okay, well we know that rows go across, don't we? Okay, so we need to find out how many rows of apples there will actually be on our stall. Okay, so if we've got 5 apples on each row, If we were to draw it, it would look like this, okay? Because you can see there are 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, okay? There are 5 apples on each row. Now take a look at mine and tell me how many rows there are, okay? So how many rows are there? There is 1 at the top and there is 1 here. How many rows are there? Brilliant! If you said 2, you would be correct. We have 2 rows with 5 apples on each row. Okay, let's look at this as a part-whole model. So, just like in my drawing, the apples have been arranged into rows containing 5 apples on each row. There are 2 rows with 5 apples on each, okay? And if we look at this on a part-whole model, it looks like this. We can see that there were 10 apples altogether. That was our whole, which we began with. And then it is split into 2 parts because we have 2 rows containing those 5 apples on each. So that's why we have our 2 parts with 5 in each. Okay, so here is our apple cart once again. And this time, again, we have 10 apples. You can check them if you would like to. And this time, we're going to arrange the apples into columns of 5. So not rows this time, columns. Remembering, columns go down. Okay, I'm going to show you my array now. Can you see how it is different to the last one? In the last example, the rows were going across, and in this example, the columns are going down, okay? So this time we have how many rows? Let me see. 1, 2, 3, 4, 5 rows with 2 in each, okay? So can you see the difference? That's what's different from this representation to the last representation. We still have the same amount, it's just arranged differently in our array. So remembering what I said earlier about the rows, this time we have 5 rows, remember, with 2 apples in each row. Will the part-whole model stay the same? What do you think? Will it stay the same or will it be different? Why or why not? Okay, so you might want to pause the video here and have a little think about what it would look like. You might even want to draw it out, or you could just have a little chat to whoever is around nearby. Okay, so if we were looking at the part-whole model for this representation, it would look like this. Because we now have 1, 2, 3, 4, 5 rows with 2 apples in each. We had 10 altogether, which was our whole, and now we have 5 rows, each with 2 apples. So I hope that that is showing in our part-whole model. I hope that you can see how it is different to our last one. Okay, what I would like you to do now is you're not going to be able, you might be able to make the arrays using something that you've got at home. It might be cubes, could be Smarties, it could be buttons. Whatever you've got access to at home, you could maybe make each array and you could discuss or think about what's the same and what is different each time, okay? So you've got 3 different arrangements to make there. And now it would be a perfect opportunity for you to pause the video and have a little go at making those arrays or discussing those arrays with the people that you've got available to you. Okay, so let's have a look at this arrangement. Again, we've got our 10 apples, and I want you to now think about what you can see. What can you say about these apples? Here's what I said. I can see 2 groups with 1, 2, 3, 4, 5 apples in each. Okay, so I've got 2 groups that I have circled, and in each of those groups I've got 5 apples. There are 2 rows with 5 apples on each. Let's look at it in a different way now. This is what else I saw. I saw 1, 2, 3, 4, 5 groups with 2 apples in each. I saw 1, 2, 3, 4, 5 columns with 2 apples in each column. Okay, so for today's independent activity, you are going to be drawing out your own arrays, okay? You're going to be ringing around the rows and the columns, and you are going to be writing one thing that is the same and one thing that is different about each of your arrangements, okay? So this is an example that I've got here on the board for you. It's what a good one looks like, okay? So you can see that here I've been asked to make 3 groups of 5, okay? So I've gone ahead and I've drawn that out using cubes. You can use dots if you want to. I've used cubes in this example. So watch my 3 groups of 5. I'm going to ring around them now. 1, 2, 3. There are 3 columns with 5 cubes in each column. Okay, so there are 3 groups of 5. Now in the second example, 5 groups of 3, you will notice that I have made that with the second representation that I have drawn. I'm going to put rings around it now so that you can see it. 1, 2, 3, 4, 5 groups with 3 in each. Here I've got 5 rows with 3 cubes on each row. Okay. Now what I'm going to do is on your work, just like you are on your worksheet, you've got a space to say what's the same and what's different about your 2 representations that you have drawn, okay? So in my example, I've said that there are 15 altogether in both representations. So in my first representation of 3 groups of 5, there are 15 altogether, 15 cubes. And also in my representation of 5 groups of 3, there are also 15 in that group altogether. You can go ahead and count them if you want, so you can check that Miss Thompson's correct. Then for my what's different about the 2 representations, I have said this. There are 3 groups in the first one, and there are 5 groups in the second. You could have said there are 3 columns in the first one and 5 rows in the second one, but that might be something that's the same for both representations. I'll let you decide that one. Okay, so it's over to you now. You can get on with your independent activity. So remember, all you are doing is you are drawing the arrays, then you are putting rings around the columns and the rows, and then you are describing what is the same and what is different about the arrays that you have made. Okay, I'm really looking forward to seeing your work a little bit later on, and I'm looking for all of that mathematical vocabulary in your descriptions. Okay, so in your parts where you're writing what's the same and what's different, you could be using all of that lovely mathematical vocabulary that you've been learning over the past few days. Okay, take care everybody, and I'll speak to you soon. Goodbye for now.